Hi and welcome back. Today we're going to be going through ACSBR AMath Prelim 2022 paper 1. So I received this paper from my former teacher because I was from ACSBR and he said he wanted me to do a little bit of a solution video for this. So I thought, why not? Alright. I'll probably get back to ACJC sometime next week if I can. So let's have a look at this paper. I think it's a fair paper. So the first question, A, B, and C are three angles of a triangle. Show that tangent C is equals to negative tangent A plus B. Alright, give me 1 minute. Okay. So, of course we know that A plus B plus C is 180 degrees, right? So therefore, we can write tangent C equals to tangent 180 degrees minus, we'll write A plus B as if it was one angle, and we'll use the double angle formula. So you have tangent A, which is 180 degrees, minus the tangent B, which is tangent A plus B, which is 1 minus, now you put the tangent 180 degrees and tangent A plus B. And note that tangent 180 degrees is 0 because sine 180 degrees is 0. So this is actually going to be minus tangent A plus B. If you want, you can write a 0 here. 1 minus 0 tangent A plus B. And from here, you can see that this is negative, just negative tangent A plus B. Okay, cool. Given that A and B are acute angles, sine A is 4/5, sine B is 5/13, find the exact value of tangent C. So we need to use some identities, right? So we're going to use the fact that, we'll use that fact that tangent C is negative tangent A plus B later. What we want to find is, we want to find tangent of A plus B first. And to be able to do that, we need to find sine A plus B, right? So let's try and find sine A plus B. Now sine A plus B is sine A cosine B plus sine B cosine A. Sorry. Sine B cosine A. Alright? So how do you find cosine B? Well, I can draw a... Oh, you can't draw a line here. Okay, never mind. We'll draw a right angled triangle. So let's do it like this and that, something like that, and there you go. This is a right angled triangle. This is 5, this is 13, and this will be, Pythagoras will tell you that this is 12. So sine B is 5/13, so that's opposite over hypotenuse, which is this one. So this is B. So cosine B is 12/13. Right? Because A and B are acute, so everything will be positive. Similarly, we can draw another right angle triangle for sine A. And you will have, this is 5, and this is, sorry, this will be 5, 4. Pythagoras tells you that this is 3. So this is A. So you can find that cosine A is 3/5. And then you can plug all of those back into this. You will get 4/5 times 12/13 plus 5/13 times 3/5. And you can simplify this a bit. So what you're going to get is 48/65 plus 15 over 65. So that will give me 63 over 65. But this is sine A plus B. We want to find tangent A plus B. So let's draw another right angle triangle. This is 65 and this is 63. Alright? And this is A plus B. What about this side here? This side over here, Pythagoras will tell you square root 65 square minus 63 square, which is 128 times 2, so 256. Okay, so this is 16. Alright? So therefore, you can find that tangent of A plus B will be equals to the opposite, which is 63, divided by the adjacent, which is 16. And that will tell you tangent C, based on the earlier result, will be negative 63 over 16. Yeah, there you go. That's the answer. The equation of a curve is 4x squared plus 6x minus 4. Find the set of values of x for which the line y equals to 6 minus 12x lies over the curve represented on a number line. Okay, so this is solving the inequality 4x squared plus 6x minus 4 less than 6 minus 12x, because the curve must be less than the line. And this is going to become 4x squared plus 18x minus 10 less than 0. This can be factorized. So we get 2x squared, 9x minus 5, so that's 2x something and x something. Should be minus 5 and plus 1 less than 0. Okay? And you can do a sketch if you need to. This will be minus half and this will be 5. So you can see from here that negative half, this is the other way around, now that I think about it. This is 2x minus 1x plus 5. Okay, this is half and negative 5. This is negative 5 and half rather. From here you can see that negative 5 is less than x less than half. And to represent this on the number line, you draw this line, and you do not need to label anything in between. You just label minus 5 and half. And because it's a strictly less than, it's an open interval, so use hollow circles rather than shaded circles. And there you go. And this is x. Okay? Cool. The cylinder has volume root 45 plus root 3. The base area is root 45 minus root 3. Find the height of the cylinder. Okay. So the volume, so the cylinder, the base area, is the base area times the height. And we don't need to do a pi because the base area, so-called pi is so-called, the pi term is already included within the base area. So actually all we need to do is find root 45 plus root 3 divided by root 45 minus root 3. So this is rationalizing. So if I do this, I will get root 45 plus root 3 squared, which is 45 plus 2 root 135 plus 3 divided by, now when I take conjugate of this, I'll get 45 minus 3, so this is 42. And let's see what this simplifies to. So this becomes 48. Now I can actually write 135 as 15 times 9. So I can factor out the root 9, which gives me 6 root 15. divided by 42. And this can further be simplified to 8 over 7 plus 1 over 7 root 15 cm, because they want it in the form a plus b root 15. Okay? The displacement of a mass when fixed on a vertical spring, simple harmonic equation d equals to a sine bt. So this is trigonometric context. T is the time in seconds, although the mass displaced from the equilibrium position 0 mm. Maximum is 40 mm, and the max first returns after 0.25 seconds. The positive value of a will be 40 because that is the maximum value that can be achieved by the function. And it first returns to the equilibrium position after 0.25 seconds. So we know that it starts at the equilibrium position and it returns after 0.25 seconds. So that is to say that 0.25b is equals to, what is the first point in which the standard sine function returns to 0? It will be pi, right? So therefore b equals to 4 pi. Okay? Find the exact value of t when the mass first reach a position 20 mm below its equilibrium position. So it starts by going above its equilibrium position. So we need to be mindful of the positions. This one is below. So we are solving 40 sine 4 pi t equals to negative 20, which is solving sine 4 pi t equals to negative half. Alright, the basic angle, which is the basic angle alpha will be equals to pi over 6. So 4 pi t is equals to pi plus alpha, because we want to solve in the third and fourth quadrant. We want to solve in the third quadrant. So ASTC, remember ASTC, and sine is first negative in this quadrant. So we're solving the third quadrant. So we take pi plus alpha, 7 pi over 6, and from here we deduce that the least value of t will be 7 over 24. Okay? Nice. Geometry proofs. The diagram shows a quadrilateral ABDE. Vertices lie in the circumference. Point C lies on AB produced, so that CD is tangent. CA and DE are parallel. Explain why angle BDC and angle ADE are the same. Okay? So, okay, this should be quite simple, I think. Angle BDC is equals to angle BAD by alternate segment theorem, which is equals to angle ADE because of alternate angles, right? We are given that BA is parallel to DE. Okay. Show that triangles BDC and EDA are similar. BDC and EDA. So we showed that one angle is given, so we need to find another angle. So we can use this angle, and yeah, okay, I think I have it. What I'm going to do is, we know that angle BDC equals to angle EDA from part A rather. Alright, so now I'm going to consider angle DBC. And I'm going to say that it's actually 180 degrees minus ABD. Due to adjacent angles on a straight line, right? Okay. And finally, because of angles in opposite segments are supplementary, with this is equals to angle this equals to angle DEA as well. angles in opposite segments are supplementary. Okay. Then you have two pairs of equal angles. Triangle BDC and triangle EDA are similar by AA similarity tests. Okay. Given that BD equals BC, explain why the line AD bisects angle BAE. So BD equals BC. Okay. So BD equals to BC means that these two angles are equal. And what's going to happen is that this angle, we just showed just now that this is the same as this angle, and this other angle is the same as this angle because of the similar triangle property. So that's what we need to show. Okay. We know that angle BCD equals to BAD. Or BDC rather. Which I don't need to restate the reason because we already know why that's the case. And we also know that angle BCD is angle BCD is angle DAE. This is similar triangles. And we know BD equals to BC. This implies angle BDC is equals to angle BCD by base angles in isosceles triangle, right? So that is to say that angle BAD equals to angle DAE. Okay, and from the diagram, that shows that AD bisects angle BAE. Okay. Cool. Part A. Prove the identity 1 plus sine A minus cosine 2A over cosine A plus sine 2A is tangent A. Okay, so we'll start from the left hand side. Okay, this looks a bit daunting, but here is a little bit of an approach we're going to try. We know that sine 2A is 2 sine A cosine A, and we can factor out cosine A. We know that tangent A is sine A over cosine A. So we try to show that we can do a cancellation that will result in giving us sine A over cosine A only. So I'm going to write out this one. I'm going to change cosine A to 2 sine A cosine A first. And for the top, I'm going to try and factor out sine A. I know that 1 minus cosine 2A is 2 sine square A. So I can write 2 sine square A plus sine A. And what's going to happen now is I'm going to factor out the sine A on the top, which gives me 2 sine A plus 1. And divide this by cosine A. Factor out the cosine A, which gives me 1 plus 2 sine A. But 1 plus 2 sine A is the same as 2 sine A plus 1 because addition is a commutative operator. Therefore, this is sine A over cosine A, which is tangent A. So that is the idea. Hence, solve the equation cosine 2b plus sine 4b 1 over 1 plus sine 2b minus cosine 4b equals to 2. The idea is to see that we're going to replace replace A with 2b. And it's a reciprocal, so we're actually going to consider this as cotangent 2b. Okay, so this is cotangent to B equals to 2. In other words, tangent to B equals to half. The basic angle alpha is tangent inverse of half, and B, and what's going to happen is now we're going to solve B. B is equals to the basic angle. Because this is 2B, we need to divide by 2. So this can be A over 2, or it could be pi minus, actually it's going to be degrees. So I will put this as 180 degrees minus alpha, divide by 2. Wait a minute. No, sorry. Tangent is positive in the first and third quadrants. So I'm going to consider only the third quadrant. So we're going to do 180 degrees plus alpha, divide by 2. Then we can still keep going because we haven't reached 360 degrees for B yet. 360 degrees plus alpha, divide by 2, and 540 degrees plus alpha, divide by 2. So this will be all of the solutions. And we can find out what tangent inverse of half is. You will actually get, everything will be in 1 dp. So we can actually just write this as 26.6 degrees in 1 dp. And actually it's 26.565 if you want to write that. Let's write it in 3 dp. Okay. Then we'll express everything in 1 dp after that. So if I do that, this one is 13.3 degrees. Then you'll notice actually each one is adding 90 degrees to the answer. So this one will become 103.3 degrees. You add another 90, you get 193.3 degrees. And finally, you add one more 90, you get 283.3 degrees. Okay, and then all of these are 1 dp. So those will be all of your solutions. Question 6. Show that the derivative of ln x squared divided by 5x is 2 minus ln x squared over 5x. Okay. So this is, we're going to start with the quotient rule. Let's start with the quotient rule. So d dx of ln x squared divided by 5x equals to we'll take the quotient square, 25x squared. It's going to be a long fraction though, so let me write this a bit longer. $25x squared. We'll keep the, let's keep the 5x first because that's the quotient rule. Differentiate ln x squared. Now the thing is that you can bring down the power 2, so you can actually get 2 ln x. So this is actually going to be 2 over x. Minus, and now we're going to keep ln x squared and differentiate 5x, which is just 5. So you get 5 ln x squared. Okay? We'll simplify this a bit. The x here and the 1 over x here will cancel out, and you can divide throughout by 5. So this is where you get the 2 minus ln x squared divided by 5x squared. Okay? Hence, evaluate this integral, 1 to e of ln x squared over x squared dx. So this is the differentiate, hence integrate kind of questions. So hence evaluate integral of 1 to e of ln x squared divided by x squared. Okay, so we know that integrating this will give us ln x squared over 5x. So let's write integral 1 to e ln x squared divided by x squared dx. Alright, now here's what I'm going to do. I'm actually going to write 5 times on the outside, and you'll see why. I'm going to write this as the integral of 1 to e of I'm going to write this as minus of this actually. 2 minus ln x squared divided by 5x squared dx. Okay? And then this is going to give me ln x squared minus 2, and what I need to do is add 2 over 5 back. So I will get integral from 1 to e of 2 over 5x squared dx. And I'm going to evaluate this from 1 to e. Okay. So I took out a 5 and so that I could work conveniently in terms of what I have here. So let's see what we get. We'll get 5. Now I already know this is minus ln x squared divided by 5x, right? Yeah. And if I integrate this, now you bring down, this is power negative 2, so increase the power by 1. Then you divide by derivative, divide by new power. This is just going to be minus 2 over 5x. Okay? And we're going to evaluate this from 1 to e. And this is 5. If I put in e here, ln e squared is 2. And this is minus 2 over 5e. If I put in e here, I also get another minus 2 over 5e. If I put in 1, ln 1 is 0. And then I add 2 over 5. Then I distribute the 5 throughout, and I'm going to get 2 minus 4 over e. So that will be your answer. Yeah, pretty cool. Factorize x power 4 minus 1 completely. Okay, so the insight here is you need to be able to see that this is actually x squared minus 1, and write this as x squared minus 1, x squared plus 1. And then we'll factorize x squared minus 1 itself. We'll get x minus 1, x plus 1, x squared plus 1. Okay? Hence, express x power 4 divided by x power 4 minus 1 in partial fractions in proper fraction. So I shall first express this as, I can actually remove 1 and add 1 back. So this is going to be giving me 1 plus 1 over x power 4 minus 1. Okay? And I can proceed to use my partial fractions. So I'm going to do 1 plus. So let me just, I'll leave this like that for now. And what I'm going to do is I'm going to write 1 over x power 4 minus 1 equals to a over x minus 1 plus b over x plus 1 plus cx plus d over x squared plus 1. Because this is a quadratic which cannot be factorized, so we need a linear at the top. Okay, so a, b, c, and d are constants to be determined in the set of real numbers. This is the set of real numbers. Okay, so let's have a look here. I'm going to probably compare coefficients because this is a non-linear partial fraction decomposition, so you cannot use cover-up rule, unfortunately. So what I'm going to do is I'm going to multiply out, and I'll get 1 equals to a x squared plus 1, x plus 1, plus b x squared plus 1, x minus 1, plus cx plus d, x squared minus 1. Okay? And let's try to expand this out. So to get the x squared term, I need a plus b plus d x squared. Yeah. Yes. Actually, no. X squared. Oh, this is minus, I think. yeah, this is minus. So this is minus b plus d x squared. Okay? So plus, and what is the coefficient of x? Actually, there are coefficients in x cubed also, so we need to resolve that. Let me write x cubed first. I'll write x squared right back later. What's the coefficient of x cubed? The coefficient of x cubed is just going to be a plus b plus c, right? A plus b plus c x cubed plus a minus b plus d x squared. And then what is the coefficient of x? Okay, this one is the slightly harder to find. This one is a plus b minus c plus a plus b minus c x, and then compare constants, you will get plus a minus b at minus d. A minus b minus d. Okay? So we are going to form a system of equations with this. A plus b plus c plus 0d. So this is equals to 0 because the coefficient of x cubed is 0. A minus b plus d. This is also 0. A plus b minus c. This is equals to 0. And a minus b minus d is equals to 1 because that's the constant term. And this is a pretty simple system to solve. I think immediately we will see that c is 0. What is a and b? And what is d? Okay, let's see. If I add equations, if I add equations 2 and 4, I'll get 2a minus 2b equals to 1. And what about d itself? So I get 2a minus 2b equals to 1. And what about minus 2d equals to 1? Okay, so that is to say that d is negative half. And a minus b is half, right? A minus b is half, and a plus b is 0. Okay, a plus b is 0, a minus b is half, so 2a is half, so a is quarter and b is negative quarter. Alright, of course you can do the method of substituting in numbers also. Okay. When you go to JC, you will learn that you can use a graphing calculator to solve this kind of equation, but it's okay. And we'll come back to the top and we'll get our final answer of 1 plus 1 over 4x minus 1 minus 1 over 4x plus 1 plus c itself is 0, so you get minus 1 over 2x squared plus 1. Right? Okay, there you go. And that should be the answer. Question 8. The spherical snowball, initial diameter is 6 cm, starts to roll on the hill. Okay, increase the volume at a steady rate of 8 pi. Show that the radius of the snowball 117 seconds after it starts to roll down. So, initial volume. Do we need to find initial volume? Let's do that. Initial volume. The initial diameter is 6, so the radius is 3. So 4/3 pi 3 cube, and this is 36 pi. Final volume, is 36 pi plus 117 times 8 pi, right? Because distance is speed times time, and in this case the volume is kind of the distance, right? So 117 times 8 is 960 minus 24, which is 936, so 972 pi. Okay, let R be the final radius of the snowball. Actually, let it be R1 to distinguish it from R itself. So we have 4/3 pi R1 cube equals to 972. So what is R1 cube? R1 cube is, this one is pi, so the pi cancels out also. So R1 cube is 1296. And you can find the cube root of this. And I think it should be 9. Oh, sorry. I think I did the wrong thing. R cube, it should be times 3/4. It should be 729. If you cube root this, you will get, yes, definitely this is 9. 9 cube is 729. That's what I remember. Okay, sorry, not R1 cube, just R1. Okay, 9 cm. Calculate the rate of increase of the surface area. So let A be the surface area. Of the snowball. And we are given that surface area is 4 pi r square, which is okay. So we need to go through the v dt and the yes, dv dt dv dr. Okay, so v equals to 4/3 pi r cube. Okay, and in fact dv dr is exactly a, and that's not a coincidence. You can prove that if you go to JC. Okay. Then we are given dv dt. We know that dv dt is a constant as given as 8 pi. From here we can find the r dt. Is it 8 pi or 9 pi? I think it's 8 pi, right? Yes, 8 pi. At the same time, I can find dA dt, dA dr, sorry. This is 8 pi r. So the r dt is the r dt is dr dv times dv dt. So 8 pi divided by 4 pi r square equals to 2 over r square. Then at the same time, I can find dA dt, which is dA dr times dr dt. So this is going to be 16 pi over r. When r equals to 9, you have dA dt simply is equals to 16 pi over 9 cm square per second. This is the exact form. If you want, you can evaluate this. Okay, coordinate geometry. Find the coordinates of B and D. Okay, this is a parallelogram. B lies on the x-axis, BD is parallel to the line x plus y equals to 3. So that is to say the gradient of BD is -1. So we can use gradient of, no, not gradient, midpoint. Midpoint of AC, which is also the midpoint of BD, which is 5/2 and 3/2. Okay, and we can use this on x plus y equals to 3. Okay, well, x plus y equals 3 is not the equation of BD. It is a line that's parallel to it. So gradient of BD equals to -1. So equation of BD is y minus y1, so y minus 3/2 equals to m x minus x1. Y equals to minus x plus 4. Okay. Of course, you could have seen this immediately. X plus y is 5/2 plus 3/2 equals to 4. So coordinates of B. So you let y equals to 0, and you will get just 4 and 0. And then you can use to find the coordinates of D. I will use the fact that the vector MD is equals to negative of the vector MB, which is the vector MB is 5/2 to 4, so that's 3/2. So this is minus 3/2, and the other component is 3/2 to 0, so this is positive 3/2. Okay, so I'll find OD using this. This is OM plus MD, which is OM is 5/2, 3/2. So this is 1 and 3. So D should be 1 and 3. Yes. Okay. So D equals to 1, 3. Okay. Nice. Okay. Show that ABCD is a rhombus. I can actually just consider the gradient of BD. There's two ways. I can consider the gradient of BD, which is -1. The gradient of AC, you can actually find that it is +1. Diagonals of a rhombus are perpendicular, and those two diagonals are perpendicular. So I give you that option. Gradient of AC times gradient of BD this is 4 actually. 4 plus 1 divided by 5 minus 0. 4 plus 1 divided by 5 minus 0. Gradient of BD is -1. So this is actually +1, so this is -1. So AC is perpendicular to BD. Also, midpoint of AC and midpoint of BD. So AC, M is the midpoint of AC and BD. Therefore, AC and BD are perpendicular bisector of each other. Which gives rise to the fact that this is a rhombus. Of course, you can also use the comparing lengths method. You can show that all 4 of these sides are equal. Okay. Calculate the area of rhombus ABCD. So I can use the shoelace method, of course. You could consider all 4 points, but what I'm going to do is I'm actually only going to consider 3 points, A, B, D. And I'm going to take twice the area of triangle ABD as my answer. Now, shoelace method, you usually have half on the outside. Because it's twice, then I can eliminate the half. So what I'm going to do is 0 minus 1, 0 minus 1, 4, 0, 1, 3. 0 minus 1, 4, 0, 1, 3. 0 minus 1, 4, 0, 1, 3. As with usual with the shoelace method, make sure that your coordinates are placed in the anti-clockwise order, otherwise you will get a negative number. So you will get 2 times half times the shoelace, then I put the initial one again. I choose my points so that I can eliminate all the as many terms as I can with many zeros. So I'll get 12 minus 1 plus 4, and just like that, the answer is 15. Okay, cool. Variables x and y are related by this equation. A over y equals b over x plus 1. Okay. So this is a linear law. So let's try to understand what's actually happening. We can write the equation as, we're going to divide throughout by 1 over a, or divide throughout by a rather. This will give us 1 over y equals to b over a times 1 over x plus 1 over a. So this is the y equals to mx plus c form. Okay. So I'm given that 0.625, actually 0.625 is 5 over 8 exactly, so I'll write it in fractional form. So we don't care about what the actual values of x and y are, we interpret it as 1 over y and 1 over x. So 5 over 8, b over a, 5 over 8 is equals to b over a times half plus 1 over a, which is b over 2a plus 2 over 2, b plus 2 over 2a. Okay. Which means 5 over 4 is b plus 2 over a. So 5a equals to 4b plus a. Okay, so that's one equation. And the other equation is 2 over 5 actually, sorry. 0.4 is 2/5. So 2/5 equals to b over a times 1/5 plus 1 over a. And let's see what this is. This is b plus 5 over 5a. 2a equals b plus 5. Then we can try and equate these two together. So we'll get 5b plus 5 over 2 equals to 4b plus 8. We can multiply out, so we'll get 5b plus 25 equals to 8b plus 16. And then you will see that 3b equals to 9, so b equals to 3, and a equals to 3 plus 5 divided by 2 is 4. Okay? Yeah. It's found that the values of 1 over x are rather small. Another straight line graph is proposed by plotting the values of x and the horizontal axis. State the variable to be plotted in the vertical axis. So we refer to this if we plot x. Okay, we plot x. So let's try to rewrite the form of this equation. If we multiply throughout by x, we'll actually get ax over y equals to b plus x. So the variable to be plotted would be x over y. Okay. find the constants A and B in terms of the gradient and vertical intercept with a linear line drawn in B. So this is actually ax over y. X over y equals to x over y equals to 1 over ax plus b over a. Right? Okay. So a and b in terms of the gradient and vertical intercept. So the vertical intercept is b over a, and a itself is the gradient. So gradient, so a is reciprocal of gradient, and b over a is the vertical intercept. So this will be the vertical intercept divided by the gradient. Okay. Explain why the curve y equals to tangent 3x plus 1 has no stationary points. Okay. So this one is, we'll differentiate this. dy dx equals to, bring out the 3, so you'll get 3 secant squared 3x plus 1. Which is 3 over cosine square 3x plus 1, which is never 0. So therefore no stationary point. That's it. Okay. Given that the gradient function of a curve dy dx is k cosine x minus 3/4 sine 2x, curve passes through these 2 points, find the equation of the curve. Okay, so we'll find that the equation of the curve is of the form y equals to k. So this is the integral cosine x minus 3/4 sine 2x dx, which is of the form k. You will get sine x plus, you need to divide by 2 here, so this will give me plus 3 over 8 cosine 2x plus c. Okay. When x equals to 0, y equals to, so this is 0, so this is 3 over 8. This is k, this is k 3 over 8 plus c. Equals to 4. And when x equals to pi over 2, y equals to sine pi over 2 is 1, so you get k cosine 2x times of pi over 2 is negative 3 over 8, so you will get 5 over 8 plus c, and you will get 0. Okay. So that is to say that 1 over 4k is equals to negative 4. So k is negative 16, and we can find c from here. C is negative 3 over 8. Okay, then but actually the constant we're adding is kc. So kc is positive 6. So therefore y equals to minus, I'll write the cosine first. So I'll get, actually no, it doesn't matter, but minus 16 sine 2x, sorry, this is 16 sine x only, minus 3 over 8 of 16 is 6, so 6 cosine 2x, and then plus 6. That will be the equation of the curve. The diagram shows an open box with a rectangular base and the closed fitting lid, which slips over the top. Dimensions are 2x, x, and 3. Total area, obtain an expression of y in terms of x. Okay, so for the lid, every side is counted except for the bottom part, and for the box, every side is counted except the top part. So we will have to consider 2x x plus. Okay, so we get 2x 3 plus 2x3 plus, then we need to consider the opening, so that is 2x squared. Then we need to consider the box itself, so this is 2x y plus 2xy plus 2x squared. Okay, and this is equals to, we'll simplify this, so bring all the terms together, so this is 4x squared plus 6xy plus 18x yeah, that's all the terms brought together already. So that is 2,400. Okay. So therefore y is actually 2,400 minus 4x squared minus 18x divided by 6x. The volume of the box is V equals to, you will see that's actually y times x times 2x, which is 2x squared. So this gives me 2,400 x minus 4x cubed minus 18x squared divided by 3x. Then I can split this into the individual terms. This gives me 800. Yeah. Oh wait, this is squared, sorry. Yeah. This is power 4 and this is power 3. Okay, so this is 800x minus 4/3 x cubed, 4x cubed over 3, minus 6x squared. So that's how you get the expression they want. Given that x can vary, find the value of x for which the volume of the box is stationary. So we have this, so we want to find dv dx equals to, so 800 minus, differentiate each term, 800 minus 4x squared minus 12x. Okay. Let dv dx equals to 0. 4, we can actually divide throughout by -4. So we'll get x squared plus 3x minus 200 is equals to 0. And then we can go ahead and solve for the value of x, which gives this. Okay. So this is going to be an irrational result. So x plus 3/2 squared. If you minus a 9/4 on this side, then you minus another 200. So this is 200 plus 9/4, which is 809 divided by 4. So you get x equals to minus 3 plus minus the square root of 809 divided by 4. And you can find the values of x. So, sorry, it's divided by 2. So you get 12.721. X equals to, the other solution will be a negative number, so we don't consider it. Okay. And then from here we find the value of v. So we take this number and we literally just plug it back into our formula here. So we get 800 plus 4. So you get 2 3SF. So V will be 6460. Okay. Explain why this value of x gives the largest volume in the box. For this, you can consider d2v dx squared, the second derivative. So this is just going to be minus 8x minus 12. When x equals to 12.721, the 2v dx squared is going to be a negative number essentially. So it's minus 113.768. Sorry. Minus 113.768, which is less than 0. So therefore this is a maximum point. Okay, that will be all, I think. Yep, that's the end of the paper. Overall, it's a fair paper. I took about 1 hour plus, a couple of carelessness sometimes, because that's what happens when I take things quite fast.